back. So that's your table. Uh, for each class, you found your frequency. When you divide by the total number of data entries you have, you get what is called relative frequency. I hope it's clear. I have copied this data, this table over here. All right. So now let's see the graph. You see, first let me look at the histogram. For histogram, you look at frequency. For the first class 1 to 8, frequency is 14. So you see, so 1 to 8 is here, but remember class boundary? We took a little to the left, 0.5, little to the right, 8.5. And that's the class boundary. And you give it height 14. The next class has height for 21. So little to the left is 8.5, little to the right is 16.5. And that gets me height 21 and so on. Now I hope you see why we go a little to the left and little to the right with the class boundaries. Okay, so let's see the class boundaries. There you go. So what do we do with the class boundaries? If you notice, 1 point minus 0.5 is 0.5, 8 plus 0.5, 8.5. 9 minus 0.5 is 8.5, 16 plus 0.5, 16.5. So class boundaries are a bit wider than the actual class. Why do we do that? We do that so that the rectangles that we draw actually touch each other. All right. So that's how, so for each class, you have a certain boundary, a little wider than the actual class, and then you would draw for the height given by the frequency. So that is histogram. So histogram is drawn using frequency. Now, relative frequency histogram is drawn using relative frequency, you see. So it's no longer 14, it's 0.23 for the first class. For the second class, height should be 0.35. You see? So the point though is, notice the shape is going to be the same. So you may as well copy this picture here and change the numbers to the relative frequency numbers. That's what it is. Okay. Shape of the frequency histogram and the relative frequency histogram is going to be the same. So this is how you take your data, divide it into classes, and for each class find its frequency using your tally. Then when you draw, you use class boundaries so that the rectangles touch each other with the appropriate height. Okay. Now, for each class of the frequency table, make a corresponding bar with horizontal width extending. Extending is the part that I was talking about. Increase by 0.5 on the right, decrease by 0.5 on the left. Okay. For a histogram, the height of each bar is the corresponding class frequency. For relative frequency histogram, the height of each bar is the corresponding relative frequency. Notice that the basic shapes of the graphs are the same. The only difference involves vertical axis. Vertical axis of the histogram shows frequencies, whereas that of the relative frequency histogram shows relative frequencies. Now, distribution shapes. Okay, so that completed histograms and relative frequency histograms. Let's look to distribution shapes. Okay, histograms are valuable and useful tools. If the raw data came from a random sample, the histogram constructed from sample values should have a distribution shape that is reasonably similar to that of the population. Several terms. So why would you look at a sample? Because if your sample is sufficiently random, yeah, then the sample reflects what actually happens in the population. Now, several terms are commonly used to describe histograms and their associated population distribution. Now, here are the terms. Mound-shaped symmetrical. This term refers to a histogram in which both sides are more or less of the same. All right. So let me maybe copy and paste so we can read off of it. Okay. With an example on the side. So that's mound shaped symmetrical. Here are the pictures. Okay, let's see. Mound shaped. This refers to a histogram in which both sides are more or less the same when the graph is folded vertically down in the middle. So if I take the graph and fold it along here, you get a symmetry. So notice it doesn't have to be identical. All right, this side could be slightly more, this side could be slightly less, and so on and so forth, but more or less symmetrical. That is mound shaped symmetrical. Uniform or rectangular. This refers to a histogram in which every class has equal frequency. So every class gets the same height. So this is therefore called uniform or rectangular, as the name suggests. Your picture is rectangular. Okay. The next one, skewed left or skewed right. And that's one of these. Skewed left, you see, the way to think about it is, where does the tail of your picture go? Tail. So this is, say, the body, and this is the tail. Tail goes to the left. So this is called skewed left. Here the tail goes to the right. So that is skewed right. These terms refer to a histogram in which one tail is stretched out longer than the other. The direction of skewness is on the side of the longer tail. So if the longer tail is on the left, we say that the histogram is skewed to the left. All right. Likewise, if the tail is to the right, you say skew to the right. Now, bimodal. Bimodal refers to a histogram in which the two classes with the largest frequencies are separated by at least one class. The top two frequencies of these classes may have slightly different values. This type of situation sometimes indicates that we are sampling from two different populations. So here is an example of bimodal. You see there is a very big high and there is not as big high but sufficiently large enough high. So these are modes, basically different modes. So they are separated by at least one class. So this indicates that maybe we used two different populations to sample out of. Okay, so this is called bimodal. Bimodal. All right. Which brings us to cumulative frequency tables and ogives. All right. So let's look at this. Sometimes we want to study cumulative totals instead of frequencies. Cumulative, as the name suggests, you're going to take total. All right. How many data values are smaller than an upper class boundary? So when you look at cumulative frequency, you're going to find out how many data values are smaller. Okay, we will see an example. Once we have a frequency table, it is straightforward matter to add column of frequency column of cumulative frequencies. The cumulative frequency for a class is the sum of the frequencies for that class and all previous classes. Okay, so I would like to show it an example. Let's worry about ogive a little bit later. So here we go. So you have the frequencies, you have class boundaries, right? You write down the frequency so far. So that's what cumulative is. Whatever frequency you have so far, you write it down. Here, you write it down and add the previous one. For the first one, there was nothing previously. But for the second one, you add the previous. That's what cumulative is. Okay. So this number plus whatever was previous, and that got you 66. Write 51 and now add the previous one. Write 27 and add the previous one, and so on. So basically, cumulative means you're adding this plus this plus this plus this plus this in all, like that. Okay. So once you have cumulative frequency, you are going to draw them together as a graph. Okay. So I would like to maybe make a copy of this for you to see how the graph is drawn.